Right, we were at 1.2 where we were required to solve for x simultaneously. Then this is 1.2 that we have here. The first value of x is x equals 1. The second value of x is x equals to 5/3. Then the first value of y is equals to 7. And the second value of y is y equals to 37/3. Now we are going to head straight to 1.3. First, let us clear some space so that we are able to indulge 1.3. In 1.3, it reads as follows. It says the equivalent resistant R of two resistors, resistor 1 and resistor 2, are connected in parallel is expressed as R, which is the resistor, is equal to R1 multiplied by R2 divided by R1 plus R2, where R1 is equal to x to the power of 3/2, and where R2 is equal to the square root of what? Of x. Then we are going to indulge this question so that we are able to clear it out. Then 1.3.1 1.3.1, it says express R. Here it's R in a simplified terms of x. What does this question say? Remember, from here we are given R1 to be x, or x to the power of 3/2. We are given R2 to be square root of x. Then where we see R1, we are going to substitute what is equal to R1. Where we see R2, we are going to substitute what is equal to R2, because they want us to simplify R, which is the resistance, using what? Using the x's that we have here as R1 and R2. Then we are just going to substitute the values of R1 and R2 where we see R1 and R2. Then R is equal to, then the value of R1, it is x to the power of 3/2 multiply by the square root of x. Everything here all divide by x to the power of 3/2 plus the square root of what? Of x. Then we still go on to say R is equal to, already here the x that we have here is already been simplified. We have an x with the rational exponent. We still maintain that as x to the power of 3/2 multiply. Then here we can't simplify because there is a square root sign. Remember, this part, it is called a square root, meaning that there is a 2 outside here. There is a 2 outside here. That's why it is called a square root. And inside the square root here, we have an x with the power. Remember here, there is nothing, but there is a 1 that is silent here as the exponent of what? Of x. Now, how do we get rid of the root? We are going to say an exponent of x that is inside, it is going to divide the number that is outside the root. In this case, we maintain the base of x. The exponent of x that is inside in this case is 1. is going to divide the number that is outside. In this case is positive 2. Everything all divide by x to the power of 3 all over 2 plus. Same principle, if we have to get rid of the root, we maintain the base of x. The exponent of x that is inside, it divides the number that is outside. Now we form what is called the rational exponent. Let us go on to simplify further. That is equal to. Now, what will happen here? What will happen here at the top? We have x to the power of 3 over 2 multiplied by x to the power of 1 over 2. Now, when we go back to the laws of exponent, law number 1 to be precise, it says when you have two similar bases, if you have two bases that are exactly the same, it says keep only one base because they are the same and they are multiplying. Remember, law number 1 of exponent, it deals with multiplication of the same bases. X and x are the same base. The law number 1, it says we maintain one base of the two. Then to the exponent, we must add them. Then we are going to add 3 all over 2 and add it to 1 all over 2. That is the top part. Everything here all divide. Now here, there is what? Same base x and same base x, but there is a plus. Then under the laws that governs exponent, there is no law that deals with what? That deals with addition. There is no law that says when you add the same bases, multiply the exponent. There is no such law. Then what needs to happen here? Since well there is an addition between the two bases, the only thing that is going to help us here to simplify is by usage of factorization. Now here, we have x to the power of 3 over 2 plus x to the power of 1 over 2. We must take an x as our factor outside because it's factorization of taking out the factor, taking out what is common in this case. Then here, how are we going to factor in x? Because we have rational exponent. The x with the smaller exponent, we are going to take it out as our common factor. I'm going to repeat that. Here we must factorize using what? Factorization of taking out what is common. Because we have the same basis of x, we must factorize. Then which one are you going to choose as the common factor? You take an x with the smallest power. In this case, 3 over 2, it is 1 over 2. Then 1, it is 1,5 in decimal. Then 1 over 2, it is 0,5. It means this one is the x with the smallest power. We take it outside. Then we have x to the power of 1 all over 2, open bracket, x. Then here as a power inside here, what must I add 1 over 2 with to give me 3 over 2 that I have here? How do you get that? You are going to say 3 all over 2 minus 1 over 2. Then in this case, it must be an exponent of 1 plus. Remember here, I took out 1 over 2 as a common factor. Here it is. I multiply 1 over 2 with what number to give me x to the power of 1 over 2? I multiply it with the 1. Because any number, any variable, when you multiply it with the 1, it remains the same. Then we still go on to say r is equal to. Then we keep or we maintain the exponent of what? Of x. Then 3 over 2 plus 1 over 2. It gives us the rational exponent of what? Of 2 here. Everything here all divide by x to the power of 1 all over 2, open bracket, x plus what? Plus 1. Then what needs to happen from here? what needs to happen from here. Then we have the base of x at the top and the base of x at the bottom. And there is a division sign here. There is a division sign here. We see a division sign here. Then we must think of law number 2 of our exponent. Law number 2 of exponents, it says, when you divide the same bases, keep only one base and subtract the exponent. Exponent that is at the top minus the exponent that is at the bottom. This one part here, it remains at the bottom here. The only thing that we consider here is these two x's, because why? Law number 2, it says when you divide the same basis, the exponent that is at the top, it must minus the exponent that is at the bottom. In this case, is 1 over 2. Then divide. Remember, what is here, what we have here, it remains there at the bottom, which is x plus 1. Then therefore, r, it will be equal to, then 2 minus 1 over 2. It results to x to the power of 3 all over 2. Sorry about that. Let us write that correctly. We have 3x to the power of 3 all over 2 divide by x plus what? Plus 1. Then this is the value of r in a simplified manner of what? Of x. That is what we have there. How many marks there? 3 marks there. Then without wasting any of the time, we indulge 1.3.2. It says determine r if x is equal to 25 ohms. Meaning, in this simplified resistor, or in this simplified equation, where we see x, we are going to substitute 25, which represent 25 ohms. Then we are going to have r, that is equal to, remember, where we see x, we are going to substitute 25, all to the power of rational exponent, in this case is 3 all over 2, divide. The value of x that we have is 25 plus what? Plus a 1. Then r in a simplified form, it will be equal to 25 to the power of rational exponent 3 over 2 divided by 25 plus 1. Then the answer gives us 125 divided by 26. That is the value of resistor. That is the value of the resistor that we have here in 1.3. That is all about 1.3, where we need to substitute the value of R1 and R2 and simplify the value of the resistor. And finally give the actual, this is in ohms, resistor in ohms. Then we are heading straight to 1.4. Let us clear some space here so that we indulge 1.4. Then 1.4. In 1.4, it says we are given the decimal number a is equal to 75 and b is equal to 5. But determine the value of 75 divided by 5. And then convert your number or your answer to a binary number. Then we are going to take those numbers as they are, to say 75 divide by 5. Then use our calculator to say 75 divided by 5 divided by a 5. The answer that we have here is 15. 1 mark for 15. Then it says, then convert this answer 15 to a binary number. Then remember, we have new calculators that are being launched or that we have bought. They have a binary number built in. Then how do we access the binary number from the latest calculators that are called Golf 8 GTI? Then in your calculator, you are going to press a mode. A mode is on the far right, on the top right there on your calculator. You press the mode. You press shift mode. Let's see, so that, yes, you only, no, don't press shift, only access the mode setup. You press mode setup on the far right, mode. Then after you shall have pressed the mode, you are given 5 options to choose. Now when you check option number 4, it is base/n, which is binary number. In this case, you press 4 from numbers 4. Then after you shall have pressed 4, on the screen you have DEC. DEC, it means you are going to write a decimal number, or you are going to press a decimal number into your calculator. And in this case, we are required to convert a decimal to a binary. Now we are going to write our decimal, in this case is 15, and we push an equal so button. You should have 15 on the far left and also 15 below DEC. Now we need to convert 15 to binary. Then you must press shift. Then you must look for LOG, which is logarithm. Above logarithm LOG, there is a bin. Then you press log. Then the zeros from the left, you don't consider them. You start from 1. Then 15 in binary, it is 1, 1, 1, 1. Remember, to show that this is a binary number, we need to have a subscript 2 at the end of the numbers. Then this will be 15 in binary. 1 mark there. That is that about the Department of Basic Education / Eastern Cape, June 2022. Mark allocation in this case 20 marks. Thank you so much. We'll see each other in my next video that I'm also going to post, because in all that I do, I'm indulging or taking learners through all sections of technical mathematics past papers, so that learners are well capacitated as to what is expected of themselves in terms of going through in addressing the question that have been asked. That is that. Thank you.